Hello class. Yeah, are we okay? Now we are back to topic 8. Topic 8. That will be topic 8. This is water. Now topic 8 is going to be water. But before visiting topic 8, a small hit back on topic 7. In topic 7 we had air, and we saw very many things. Then I would like to give you 2 research questions before we introduce in topic 8. Let me give you 2 research questions on topic 7 about air. Question 1, put it down, and the research places will be the library. You can visit the internet using the Google search engine. Then you can visit some friends who know some chemistry and make a discussion. Question 1, put it down. Describe briefly a simple experiment using the scientific method. Describe briefly a simple experiment using the scientific method to determine the percentage of air to determine the percentage of oxygen in air. To determine the percentage of oxygen in air. Then question 2, rusting. Question 2, rusting, part A. What is rusting? Then part B, describe the conditions necessary for rusting to take place. Describe the conditions necessary for rusting to take place. Part C, briefly describe experiments to show that each condition is necessary. To show that each condition is necessary for rusting. Then part D, mention 4 ways by which rusting can be prevented. You'll present that work. Do research using Google search engine or library textbooks. Now let's switch to topic 8. Now for this time we are looking at our topic 8, and in topic 8 we shall break it down into several subheadings, and those will be our subtopics. We shall look at the chemical nature of water. How is water chemically? how is water chemically. Then 2, we shall look at sources of this water. Sources of water. Then 3, we shall visit the uses of water. Then visit the physical properties of water, physical and chemical properties of water. Chemical properties of water. Then we look at the chemical tests for water. How do you know that the liquid is water? How do you know that the liquid is water? Then purity of water. Purity of water. We shall also visit the water cycle. Water cycle. See, then we also we should visit the something on water pollution. Water pollution. And finally, we should look at the sewage. The sewage and water treatment or water purification. Water treatment or water purification. Or water purification. Now right away, without wasting time, let us visit the chemical nature of water. Chemical nature. The nature we mean in what is the chemical symbols, chemical elements that make up water. Chemical nature, we mean what are those chemicals from which water is made from. Now, we visited some time back here. We looked at elements, compounds and mixtures. You remember that? Yeah, exactly. Now, water is a compound. Water is a compound. That's why we are saying the chemical nature of water means the chemical elements that make up water. Could somebody be aware, water being a compound, which elements are mixed chemically to form water? Which elements are mixed chemically to form water? Yes, Patience, can I hear from you loudly? Hydrogen and oxygen. Now, those two elements must be mixed chemically. Hydrogen plus oxygen reacting together form water. And that occurs in the presence of energy called heat. That means the chemical nature of water, or the chemical elements that make up water, is hydrogen and oxygen. But incidentally, this hydrogen is in much proportion than oxygen. Every water molecule contains 2 hydrogen atoms and 1 oxygen atom. And we saw some time back there that in compounds and elements, we say the symbol for hydrogen is H and the symbol for oxygen was O. And since water has 2 atoms of hydrogen, that gives us water. Now, the chemical nature of water is that water contains 2 atoms of hydrogen and 1 atom of oxygen. That's the chemical nature of water. So now running very fast to the sources of water. Sources of water. This one, I know it's a common thing to you because you have water at home and you know where you get water. Could you get down and discuss a few sources of water at your places of residence, at your homes? Just like 3 sources are enough. Yeah, let us have patience taking that through the different sources of water. We have rain.
We have springs.
We have springs. Rivers. Lakes. Wells.
Then boreholes and swamps.
Boreholes and swamps. Yeah. Those are the very many sources of water that we have, including more others like oceans. Is that very, very correct?
Yeah.
Now let us shift very fast to uses of water. Where do we use the water? This lesson is so interesting that it is a simple lesson for you. Yeah. Uses of water. Could you discuss some 4 uses of water? Discuss some 4 uses of water. Yeah, Aspolo, take us through the various uses of water.
Water is used for drinking.
Water is used for drinking.
For bathing.
Bathing.
Washing clothes.
Washing clothes.
Cooling machines in industries.
Cooling machines in industries.
It is used by plants for photosynthesis.
Used by plants for photosynthesis.
Then used by people to irrigate their plants or crops.
Used in irrigation of plants. Yeah, that's very, very great. I think we can't add something to that. Now let's turn very fast to the physical properties of water. Physical properties of water. Physical properties of water. Physical properties of water. Now turn here with me. The word physical means what can be identified using our senses, like sight, we can see, we can taste using the tongue, we can also test this water using the thermometer. Yeah. Then we can also smell the water. Those are the physical properties. I will be receiving an answer one person at a time. Patience, what is the physical property? First physical property?
Water can be seen.
It can be seen. When you see water, what are you seeing?
Water is color.
Or colorless. You have seen that it has no color. Water is colorless. Then to Aspolo.
What is odorless?
Water is odorless. What do you mean to be odorless?
Has no smell.
Odorless, that means has no smell. Patience.
Water is tasteless.
Water is tasteless. Tasteless has no taste. Aspolo.
Water boils at 100 degrees Celsius.
That means using the thermometer, the boiling point of water is 100 degrees. See, boiling point is 100 degrees Celsius. Then what's the melting point of water?
0.
And it melts at 0. Melting point is 0 degrees Celsius. Okay. Now, you have more, Aspolo?
What does the density of 1 gram per cubic centimeter?
Yes. Density is 1 gram per cubic centimeters. That's the density of pure water. Now listen. Pure water boils at 100 degrees what? Celsius. That we will do now mix that concept with the purity here. Listen. It's only pure water that can boil at 100 degrees Celsius. Clear? Now, and it's only pure water that can melt at 0 degrees Celsius. Clear? That means contaminated water is not pure water. To contaminate water is to add any substance that can dissolve in the water, like adding sugar, adding table salt, makes the water impure. Clear? Now, even water that is not pure has a density which is not 1. Clear? Now listen, that means we can talk about the purity of water. How do we determine that the water is pure? We use the 3 physical properties. We can check its boiling point, we can check its melting point, then we can check its density. Is that very right? Now listen. Boiling point and melting point are affected by 2 factors. Boiling point and melting point are affected by 2 factors. That is pressure and impurities, contaminants. Listen, when you go, you see, pressure, or the pressure that affects the boiling point of water is in fact called atmospheric. The pressure that is around us, air pressure, the pressure of the surrounding we are in. Now, on the mountain, that means above sea level, above the ground that we are staying in here. When you're on the mountain, see, the pressure reduces with the height. As you go up, pressure reduces. Now, down here where we are, the pressure is a bit higher than the one on the mountain. That means when you're on the mountain, the boiling point will be lower than 100. See, that means when you start boil water on the mountain, it can boil like at 98. See, somebody can get surprised by cooking on the mountain. Cooking will take, you see things boiling very fast. Now the boiling point and melting points are lowered when you're on the mountainous what? Area. That's why they say the higher you go, the cooler it becomes. The melting point is lowered very, very much on the mountain. See, that means How does pressure affect boiling point? The higher the pressure, the higher the boiling point, and the low pressure lowers the boiling point. Now density here, we mean if you have pure water and salt water, this one can be a demonstration experiment at home. When you go back home, demonstrate this. Get salt water, get salt, table salt, put it in water, then also get water that does not have table salt. Then the two, get an egg and put in the two. We are now trying to look at this density factor here, that pure water has a density of 1, but when you add the contaminants, you make water heavy, more dense. See, now look here, that in pure water here is more dense because some things have dissolved in it. Then pure water here is less dense. Now listen very, very much here. When pure water has a density of 1, when you add in a substance, you make water dense. Now, at home, you will demonstrate using an egg. An egg has a density of around 1.1. Now, when you add the table salt in water, you make water impure. Now, when you put, you try to put an egg, you try to put an egg on in pure water, and you put it in pure water. In one of them it will sink, in one of them it will float. See? This one I want you to try it at home. That in pure water is more denser than pure water. See? That means when you have pure water and you put in an egg, and you get again the same egg and you put in pure water. See? If in pure water is more dense and pure water is less dense, where will the egg float? See? That one I need you to do it at home. Get salt water, get some salt, dissolve in water, then get water that is pure in the two, put in an egg, then carry out an observation. You realize that in one it will sink, in one it will float. See, now that means impurities affect the density of water. It does not remain 1. So now that's all. That means we have checked the physical properties and the purity of water. Now listen here, we are still here. Very, very pure water. In our integrated science in primary, what did we say pure water? Is pure water acidic? What is the chemical, we call it the pH of water. What is that chemical part of water? Is it acidic? Is it neutral? How does it taste? Now listen, there are three tastes. There is an acidic taste on your tongue, there is a neutral taste, and there is what we call alkaline taste. See? Now, an acidic substance tastes sour. The taste is sour. I hope you normally taste those mangoes, and I don't know, is the mango bitter or the mango is sour? You see? Now, a neutral taste is tasteless. Is that clear? An alkaline taste is bitter. So, now, water is tasteless, meaning water is neutral. So, listen, water is neutral. Now, in this chemistry here, scientists invented a scale to identify acidic substances, neutral substances, and alkaline substances. We are still on the physical properties of water, of which one of them we are looking at the what? Water is neutral, or water has a pH of 7. Clear? Now, scientists invented a scale called the pH scale. pH scale runs from 0 to 14. But it has 1, 2, 3, 4, 5. This is a pH scale to find out whether water is neutral, acidic, or alkaline. See? 8, 9, 10, 11, 12, 13, etc. Now we said to be acidic is to taste sour. See? To be neutral is to be tasteless, and that's our water. To be alkaline is to be bitter. Now on the pH scale, neutral substances had a pH of 7 being tested. Then this side was for acidic substances. If you are acidic, your pH is this side. Then alkaline substances, those that tested bitter, had a pH above 7. So now, when you are very, very sour, see, then the substance is too acidic. When you are too acidic, the pH is very low. That means you are very, very sour. See? You are very, very sour, causing you to have a pH of around 0, 1 to 3. Then if you are sour a little, you are less acidic. That means more acidic is here, more sour, rather more acidic. More acidic. See? Then here you are less acidic. Less acidic. That means you taste little sourness. See? Then here from 13 to 14 here is very alkaline, too bitter. It is very bitter until you close eyes. That means the pH is around very alkaline. Very, very alkaline. See? Now here it's very less alkaline. That's the pH scale by our scientists. That means if you are gauging your lemons, you know where the lemon lies. Use your tongue to establish the pH. See, you can get your mango, taste it. To be more acidic is to be very sour. See? And to be very bitter is to have a pH of around 13 to 14. That's very, very right. Now, that has taken us to living the physical properties of water. The last physical property was that water is neutral. That means water has a perfect pH of 7 if it's pure water. Now, this pH scale is used to show acidity, neutrality, and alkalinity. So, are we listening very, very attentively? So, now again, scientists, in addition to the pH scale, invented what we call indicators. And the basic indicator at this level of ours is litmus paper. See? Now, the pH scale tells us whether the substance is acidic, neutral, alkaline. The same is the indicator. An indicator is the substance that shows whether another substance is acidic, neutral or alkaline. See, indicator, what does it show? Shows acidity, neutrality, alkalinity, like the pH scale here. See, now the litmus papers are blue. They have two types, blue and red. Blue and red. Water, that one we are going to demonstrate it there. Water is neutral. See? To be neutral is to have no effect. To have no effect. See? Now, before I continue speaking about these indicators and litmus paper, I would like you to show us how water is behaving on blue litmus paper and red litmus paper. Then we go on with the discussion. Yes, somebody present to us water is here. How water behaves on blue litmus paper and red litmus paper. Yes, patients, raise it up. Which paper is that? Blue. Has it changed? No. Water has no effect on blue litmus paper. There is no effect. Now listen, that means water is neutral to litmus paper or has no effect on litmus paper. Now that means a neutral substance will not affect litmus paper. Now an acidic substance, if you had like lemon juice and you pour on a blue litmus paper, it will turn red. Red litmus paper will remain unturned. It will remain red. An acid like lemon juice changes blue litmus paper red. You can try that at home. Get lemon juice, pour on a small piece of litmus paper. Red will remain red. Alkaline substances like baking powder. You can pick baking powder at home, taste it on the tongue, add in some little water and taste it. It is alkaline. And if you taste baking powder with blue litmus paper, remains blue. Red litmus paper turns blue. Alkaline substances will turn blue litmus paper, will not affect blue litmus paper, but alkaline substances will only affect red litmus paper, turning it blue. I've given you two substances here, lemon juice and baking powder at home. Baking powder is alkaline, lemon juice is acidic. Now, let us leave this part alone under physical properties of water. Shifting very, very fast here to the chemical properties of water. Chemical properties of water. Chemical properties of water. Now, we know from integrated science in primary that water is a universal solvent. What did they mean to be universal solvent? Anybody can help us understand that? Water is a universal solvent. Patience, what do you mean by universal solvent? It means it can dissolve all solutes, or rather can dissolve all substances. See, Now, the word all here means some. In integrated science, we say the all, but at secondary level, we say water can dissolve most substances. The word all here changes to most. Now, to dissolve in water is to react with water. Clear? Most substances react with water, or most substances dissolve in water. Now, chemical properties are what we call the reactions, because a chemical property is simply a chemical reaction. When we say chemical properties of water, we simply mean water being a universal solvent dissolves very many substances or reacts with very many substances. For example, it can react with, which substances do we have in category? We saw a periodic table back there that it has what we call metals. That means water can react with metals. See. And we shall not go into deeper details here how water reacts with metals, just giving a highlight that water reacts with many substances, or rather water is a universal solvent. To react is to dissolve those substances and form a new product. Water reacts with metals and many other substances. Okay, now shifting here to the chemical test for water. Chemical test for water. See? Now, when we add the word chemical, we mean the change is going to be a chemical change. When you say chemical, then there must be a new substance that is formed. See? Chemical test for water. Now, this one I'll ask you to, I will not explain what we see, but I'll give you two substances. I'll give you an alcohol, pure alcohol, and I'll also give you pure water. You'll use two petri dishes, and on each you add to a substance. You add to a substance called the anhydrous copper 2 sulfate. When you add it to that substance, I will ask you what we see. What do we see? Then we shall discuss how water is tested chemically. To test chemically is to react water with something else. Now, aspiro, you'll use alcohol. Then patience, you'll use water. You'll drop some little water on anhydrous copper 2 sulfate. That means remove that one, then put some little anhydrous copper 2 sulfate. Could you dry that? Yeah. As you organize to add, that means I will require two petri dishes. One, put anhydrous copper 2 sulfate powder. Then another, and also put the same white anhydrous copper 2 sulfate powder. Patience, you will add a few drops of water. Aspiro, you will also add a few drops of water. Put white anhydrous copper 2 sulfate. One spatula is enough. carefully add some water there and tell us what you see. Let it touch the anhydrous copper 2 sulfate. Yeah, now lift that up. Patience, you added water on white anhydrous copper 2 sulfate. Then Aspolo added pure alcohol, and we see that Aspolo, you tell us what you saw. Then Patience, you tell us also what you saw. Patience, tell us what you added and what you have seen.
I added water in the petri dish where there was anhydrous copper sulfate.
What happened?
Anhydrous copper sulfate.
From which color? From white to blue. Then Aspolo, you added alcohol. Tell us.
When I added alcohol to 1 spatula of anhydrous copper sulfate, it remained white.
It remained white. Yeah. Thank you very much. Now, on Earth here, almost every substance has some little in it. That's why most times if you add water, you add any substance to white anhydrous copper 2 sulfate, it might turn to blue, because most substances on Earth have water in them. However pure it is, even if it is petrol, still there will be a component of some little water that went in it from water vapor in the atmosphere. See, that means you cannot escape water. Now, anhydrous copper 2 sulfate is a chemical test for water. It must turn from white to blue. The turning from white to blue, the word anhydrous means it has no water, it's a powder. Then when you add water to it, the substance becomes, it's now called hydrated copper 2 sulfate. Now that one, the test was a chemical reaction. Anhydrous copper 2 sulfate plus water, anhydrous copper 2 sulfate plus water. Now it changed to a new substance because there was a color change there, and what it changed to is called hydrated copper 2 sulfate. I think you get that right. Yeah, that when it has no water, when it has no water, it is called, the English word anhydrous means without water. Then when you add water, it gains water to become hydrated. This substance is white, this is blue. That makes it a chemical test because it involved a chemical reaction. Now, leaving that alone, let us drop very fast to the water cycle. Water cycle. That one we shall speak about it briefly. In integrated science of primary, you had something about water cycle, how water comes to us on Earth and how it leaves us. Anybody with some knowledge on the water cycle? Yes, let me have one of you, Patience, taking us through the water cycle.
Let me give an example of a river. of a lake. The sun hits the lake and the sun hits the lake and the heat from the sun makes the water to evaporate to the clouds and to form water vapor, and that vapor forms clouds. And then the clouds condense to form rain, and the rain goes into the lake again.
Okay. Is that all? Yeah, thank you very much. That's very great. Aspolo, can you add something to her?
What I say, it starts with two processes. First of all, for the water bodies, there will be evaporation from these water bodies, and also plants, there will be is what we call transpiration. These plants will also lose water to the atmosphere, and when this water, because that is water vapor in the atmosphere, it will condense to form nimbrous clouds, and these nimbrous clouds are the ones that give us rain. So when they condense, on cooling, they will give us rain here.
Okay, thank you very, very much. I think on the water cycle, they are very, very good students. They are presented so well, but we can just add something small to their information. They said there are trees somewhere. Then there is also lakes. Did you say they were lakes? There is a lake here, and also some mountains. Yeah. Then up here you have got your clouds, not so? Now, you say the plants are giving us water by a process called transpiration. Then water bodies are losing water by evaporation. Also land here loses water, and here is our sun shining. Now water from the earth is going by which process? This is the soil. Soil is losing water by also evaporation, not so? Evaporation, transpiration, evaporation from a mountain, a mountain. This is our mountain, also losing water, and these are the clouds which have got that water by condensation, not so? Yeah, then you are saying these clouds again follow back as rain, not so? They follow back as rain. This is rain, but this rain can also be in form of what we call precipitation. Is that right?
Yes.
Precipitation is what? What's precipitation? Fog. Fog forms. All forms of water in the atmosphere is called precipitation. What of if water is falling like ice particles, snow? It's also precipitation. That's good. Yeah, thank you very much. Now that's simple water cycle, not so? You can have that illustrated. Visit the Google search engine on internet and get better and more improved diagrams. Now, now we are shifting very fast here to water pollution. Water pollution, then we see that we come to the end. Water pollution. Now somebody can define for us what's water pollution. What's water pollution? What's water pollution? You defined for us air pollution last time. Aspolo, what's water pollution?
Is the addition of impurities to water.
Is the addition of impurities. Can you become more elaborate? Explain more. You like using the word, highlight us. What are impurities that you are talking about?
Impurities are like dangerous substances in water.
Okay.
Things that may make it become harmful, toxic and dangerous for life.
It's simply the introduction of harmful or toxic substances that are dangerous to living organisms, not so? Now, what are the signs of water pollution? How do you know that water is polluted? I think I'll also leave you to handle that. Then I'll also need the what causes water pollution? Causes of water pollution. You'll also handle that. Then you'll also handle causes of water pollution. Then we shall now jump and handle what we call the sewage. Now you remind us what's a sewage also, and how is a sewage handled in urban areas. Okay, water pollution, we've defined it. What is signs of water pollution? Yes, I receive answers. Yes, patience. In order that pure water does not smell, not so? If it's contaminated, it will smell. Yes, Aspolo? Change in taste. Change in taste. That pure water is tasteless, but contaminated water can taste even like an acid.
Change in color.
Change in color, yes. Pure water is colorless, therefore impure water is colored, not so? Only change in boiling points and melting points. And boiling points and melting points. That's very, very good. Yes, patience? Change in density, yeah. Change in density. Density changes. Somebody with another answer? Or that's all? Yes.
Increasing diseases like cholera, waterborne diseases.
That when diseases start to be in water, waterborne diseases are a sign of water pollution. Yeah, thank you. Now let's shift. What causes water pollution or sources of water pollution? Which substances or which places are responsible for polluting this water? Especially industrial wastes are pollutants to water. Industrial wastes. Yes, Aspolo?
None of times, but even like in our communities, where people keep on disposing their rubbish.
That's household activities.
Yeah.
Household activities like disposing rubbish. Disposing rubbish. Can we have another?
Washing.
Yes, still household activity. Washing in water bodies. Washing in water bodies. What else? Are you thinking of more? Running water from?
That is carrying waste.
Running water, transporting wastes. But where are they from? Don't your farms also give us chemicals? Chemicals like pesticides from farms, not so? Chemicals like pesticides from farms. Pesticides from farms. Yeah. Any more hospitals also? Waste from hospitals? Also? Okay. Let us go to a sewage. What's a sewage? A sewage. Who knows what a sewage is? Sewage. Have you seen dumping places for all the wastes? When they come and remove fecal wastes from the septic tanks, they go and deposit in the what? The sewage. Some rivers end up pouring in the sewages. They carry dead bodies. Even hospitals, their pipes are connected to the sewage. That simply means a sewage could be dirty water containing wastes from factories, hospitals, homes, industries. Has that been captured very well? Is water containing wastes from hospitals, homes, industries. Now, look here. Look here. Sewage treatment. You see, science has greatly improved everything. See, this sewage we are saying has wastes, including your own feces and urine, and all the detergents, the chemicals, dead bodies is not left there for what? In fact, in countries which are deserts, this is very important place for water, for providing us with water. See, these sewages are converted to useful water, which is returned back in the lakes. See, does that sound very, very normal? That a sewage having dead bodies, feces, see, having chemicals is returned back for drinking. Could you imagine you drinking a sewage, yet it is true that you drink a sewage? See? Now, we want to see how is a sewage treated until that water is returned back into the rivers. See? Yeah. That's right. They return it back for you to drink it. So, like when they tell you that you see some scientific processes are a bit funny, that they seem unbelievable, but there are many water engineers that help us convert this sewage into pure water. Now look here, how is a sewage treated in urban areas? This sewage is returned back in lakes, rivers, and oceans. Now, it undergoes through 4 main stages here. The first stage of changing a sewage to useful water. You need to watch here very, very closely. That the first thing they do to a sewage, first stage, there are 4 stages in sewage treatment. Sewage treatment, we mean making a sewage useful again. Useful again. The first stage in sewage treatment is what we are calling screening. So, now we are going to discuss what is screening. What does it mean? Now we are discussing stages of sewage treatment. How is the sewage made useful again? See? Now sewage is called we can call it liquid water wastes. Liquid water waste. sewage treatment. Now you need to listen very attentively because some of you are going to become water engineers tomorrow. Now, how is a sewage treated? First stage is screening. Let us first list the stages. The second stage is called the primary stage. The primary stage, second stage is the primary stage. Primary stage. And that stage is called sedimentation. What takes place there is sedimentation. Sedimentation takes place here. Here there is what we call, we shall explain further what do we mean by sedimentation here. Then there is that third stage called third stage of sewage treatment. Third stage is called what? The secondary stage. Secondary stage here. That one is a stage for breakdown of organic matter using aerobic bacteria. Breakdown of organic matter using aerobic bacteria. Breakdown of organic matter using aerobic of organic matter by aerobic bacteria. Yeah. Now the last stage is called the tertiary stage. The fourth stage is the tertiary stage. Now that stage involves separating that stage is the stage in which the water is now released to enter the water bodies. Tertiary stage. So we call it separation of sludge from effluent. Sludge from effluent. Separation of sludge from effluent. We shall discuss what's effluent there. Now those are the four major stages in sewage treatment. Now look here. When the sewage is being treated, the first thing they do is to remove all the large pieces of materials they see. First stage is screening is the removal of large pieces like dead bodies, decaying organisms, jerry cans, pieces of wood, timber. Every big material is removed at this stage first. That is the first stage. They first remove anything big. That's called screening. Then the secondary stage, or the second stage is called primary stage, is sedimentation. Water is allowed, that sewage is allowed to enter what we call a sedimentation tank. Yes, they allow them to enter very, very big tanks called sedimentation tanks. And in the sedimentation tank, at the bottom, they have put large scrappers. Now, a sedimentation tank allows the sewage to stay in one place, stationary. It keeps the sewage in one place, and the sewage is stationary. When the sewage is stationary, any material that was not removed at this point that is a bit smaller, now settles at the bottom because the sewage is stationary. Now at this bottom of the sedimentation tank, they have put large scrappers, things that can scrap this this material. That material is called sludge. That solid part of the sewage that has settled down is called sludge. Now the large machines called scrappers are put at the bottom of the sedimentation tank. Scrappers are put at the bottom of the sedimentation tank, which scrap off this sludge, this solid substance, and it is designed in such a way that they scrap off, it is taken somewhere for use. Sludge is very important. Now from the primary stage, water is taken to the secondary stage. In the secondary stage, they introduce there, say, of course there is bacteria already in the sewage. It is already contaminated. What they do, they blow in some good conditions to enable bacteria to break down some solids that remained in the sewage after these two stages. That some organic substances like plants, small pieces of plants which were decaying, small pieces of cotton materials, they blow in air at the secondary stage and also maintain a suitable temperature of around 30 to 35 degrees to enable the bacteria to decompose any organic material that is remaining in that sewage. At that stage, and this one is also taking place in a sedimentation tank here. It is taking place in a sedimentation tank where the sewage has been left stationary and they are bubbling in more air and maintaining a suitable temperature. Now those organic matter that has decayed now settles at the bottom of the sedimentation tank again. In the tertiary stage now, the scrappers at the bottom again can remove the remaining solids that are finally settled at the bottom and take that sludge material somewhere. Then the liquid that is remaining is what we are calling effluent, and that is let into water. At that stage is now almost free from all the dangerous substances. It can be allowed to fall through over a wall and introduce into the lakes at that tertiary stage. Separation of sludge from effluent. Sludge is that solid material that has been gathered here due to decay and has been scrapped off by scrappers, leaving alone water. That watery part of the sewage or the liquid part is what we are calling effluent, and it's what flows in the lakes and rivers. And now that's how a sewage is handled in urban areas. The last part is water treatment. Despite releasing the sewage in water, we can't drink water from lakes like that. Water in lakes and rivers is subjected to a last stage called water treatment. Now let us discuss the last part called water treatment here, and we shall see where to close the lesson. We have discussed sewage treatment. Now water treatment. How is water purified from lakes? See, do water engineers just from a lake supply it to our homes? No. See, remember in lakes also people died there. Jerry cans go there. Wood flows there. Now we are looking at water treatment, water purification from lakes. Now after it through the tertiary stage into the lakes, then it is purified from lakes and rivers and placed in our homes by the water engineers. Now, how is water treated? Also go through a number of stages here. The first stage, of course, is always screening. Remember, water also carries large materials. Lakes have large materials. See, the next stage is aeration of that water. See, aeration. And that is what we call a coagulation and flocculation. Then filtration, Then that next stage is called chlorination, or they can use ultraviolet light treatment, ultraviolet treatment, or ozone treatment. Ozone treatment. Then lastly is neutralization. Now listen as we go through very fast through these stages of water treatment. Of course, water from the river is first screened. To screen is to remove any large piece of material like jerry cans, dead bodies, wood. Every large material is removed at the screening stage. See, is that very, very correct? Yeah, screening stage. See, screening what? Stage. Now screening, they first remove large materials, wood, dead bodies, diapers, I think you know them, nappies. Yeah, because some people throw nappies in lakes, don't they? Haven't you ever thrown one? See. Now next stage is aeration. Water, more oxygen is bubbled through water to enrich it. Yes, they enrich that water with oxygen. See, it is done by either stirring the water. See, they can stir through, then oxygen dissolves in the water. Then next stage is coagulation. To coagulate is to come together. Small particles coming together is what we call coagulation. Now in coagulation stage here, water in coagulation stage here, see, water is allowed into what we call a sedimentation tank. See, a sedimentation tank, and in that sedimentation tank they add there a chemical called aluminium sulfate. Aluminium sulfate, or sometimes we call it potassium aluminium sulfate, or just aluminium sulfate. This aluminium sulfate, now after removing large substances, aerating it, subjecting it to coagulation and flocculation in a sedimentation tank, then they put in potassium aluminium sulfate. Any small particle that is moving around, like ash, some sand, some food particles, this potassium aluminium sulfate brings every small particle to come together with other small particles to form large particles. That small particles coagulate to form big particles called flocks. That's where the word flocculation comes from. The big particles that are being formed by coagulation are called flocks in this sedimentation tank. Then this aluminium sulfate is the one that brought about coagulation. Then these flocks settle at the bottom of the sedimentation tank and are now subjected to filtration. Filtration is achieved by using layers of sand. See, water from the sedimentation tank is passed through layers of sand. Sand layers have been organized where there are large sand particles, other layers have medium particles, other layers have very tiny particles of sand. When filtration is being carried out, water is passed through layers of sand here, which are arranged big particles, medium size, very small. When water is flowing through these sand layers, it is undergoing filtration to capture any flocks that had been captured in the sedimentation tank here. Then from here, water is now treated with chlorine to kill germs, or they pass their rays from what we call ultraviolet radiations. There are some light rays which kill germs also are called ultraviolet radiations. Or they can use ozone treatment. They can bubble ozone in water. Ozone also kills germs. Instead of using chlorine, they can use UV treatment. Now most schools are now employing the UV treatment. You have those water tanks at school which they kill germs using UV, but this is disadvantageous in that germs are only killed in the tank. Then when it is flowing in a pipe, any germs is again recollected. But chlorination is better because it goes with the water and kills every germ wherever it goes. Even ozone treatment is also limited. It has some disadvantages. Then finally, neutralization can be done in case you use chlorination, because chlorine makes the water a bit acidic and it will taste bad. They neutralize that water to bring it back to the neutral taste by adding their sodium carbonate to water to make it gain back the neutral pH. See. Now that's about water treatment. Lastly, in closure, let us speak briefly on what we call what we call types of water. Types of water. We have hard water and soft water. Now, I will not speak much here, but I will ask you to, if you have heard of those terms in integrated science, you talk to us. What is hard water and what is soft water? Hard water. Anybody with any information? Yes. Let me have patience taking us through hard water and examples, soft water and examples. Then Aspolo, you'll help us with some ways to make water soft.
Hard water is the type of water that doesn't form lather easily.
That doesn't form lather easily with soap.
Yes.
Yeah.
Then soft water is the type of water that forms
lather easily with soap.
Examples of soft water have rainwater.
Rainwater.
Then hard water, there is tap water.
Tap water.
Spring water, like that.
Any water from underground is called hard water because it's contaminated with some salts. Okay, Aspolo, how do we make hard water that does not form leather easily to form leather?
Ways of making the hard water to become soft. First of all, we have temporary hard water and permanent hard water. For the temporary hard water, it contains salts such as calcium, hydrogen carbonates, and magnesium carbonate. So to make this water soft, in a way that it can form leather easily with the soap, we can just boil and this water will become soft.
Yeah.
We can also use distillation, just as this one is now expensive for homes. So in homes, the simple method is by boiling. Then we have what we call also permanent hard water, that which contains calcium sulfate and magnesium sulfate. This water to be made soft in a way that it can now form leather easily with the soap. For example, tap water. We can use distillation, though that one is expensive. Then we can add washing soda to the water, and we can also use what we call sodium perlitate. When we add sodium perlitate to water, it removes those sorts of Like the south, it's not because they have missing water.
Okay.
Yes, we make that water safe.
Yeah, we can't add anything to that. Aspol has been very, very clear ways of making water soft. We can boil, add chemicals, we can use distillation, add chemicals like sodium perlmutate, washing soda, etc. Okay, we shall not exhaust very much the details of hard water. Now I want to summarize through what we have discussed here, then we close the lesson, the topic 8. We discussed chemical nature of water, and we said water is a compound of hydrogen and oxygen. Then we went ahead to discuss the physical properties of water, chemical properties of water. We said what makes them chemical is water can dissolve many substances and react with them. We discussed the purity of water, the chemical test of water using anhydrous copper 2 sulfate. We went ahead now to introduce in the water cycle. Then we again brought in went deeper into water pollution, then went in sewage treatment, and finally we've ended with water treatment, going through screening, aeration, coagulation and flocculation in a sedimentation tank. This one's in a sedimentation tank. That means there is some sedimentation there. Then we went through filtration, chlorination, neutralization. That was the end. Now, thank you for being good students. I would like to give you this activity of integration, and we meet in the topic 9. That will be the last topic in the syllabus of Senior 1. Activity of integration, you can put it down. Clean water is important to a person's health and lifestyle. Clean water is important to a person's health and lifestyle. And it is engineers who ensure that our water is safe to drink. And it is engineers who ensure that our water is safe to drink and use. Environmental and civil engineers help maintain the quality of our water resources. Environmental and civil engineers help maintain the quality of our water resources. So, write a short newspaper article explaining what water quality is. A newspaper article explaining what water quality is. See, giving examples from your experiences of good and bad water quality. Giving you examples from your experiences of good and bad water quality. See, and what might be the cause of bad water quality, and what might be the cause of bad water quality. Now we can stop there. That's the end of our lesson. We meet in the last lesson, topic 9. Thank you.